All right, so in all of our lessons that we've done so far in this unit, lessons 1 to 4, we've been working with what we call identities. So it's important to understand the difference between an identity and an equation. They're actually two totally different things. An identity is true for all values of x that we could plug in. So for instance, if I'm thinking about the identity tan x equals sine x over cos x, as long as I plug in the same x for all of my x's here, this will always be true. Okay, so I could plug in, if I'm working with degrees, I could plug in 30 degrees, 30 degrees, and 30 degrees, and I will get left side equals right side. That's what an identity is. It means it's true for all values of x. But we're going to be working for the second half of this unit with equations. And equations are only true for some values of x. Okay, so if I say something like sine x equals negative 0.75, this is not true for all values of x. This is only true for some values of x. So identity means any value of x, this equation is going to, or this identity is going to remain true. Left side will equal right side. For an equation, we have to solve for the x that makes this true. We have to solve for which x is going to make left side equal to right side, right? So only true for some values of x, which we will solve for. So with an expression like what I just wrote, sine x equals negative 0.75, we have to remember, we did some of this in grade 11 as well, but we have to remember that there may be multiple solutions to an equation like this, mainly because of the cast rule, because I know that there's actually two quadrants between 0 and 2 pi in that rotation, where sine will be equal to a negative value. So just remember, we're going to use the cast rule here. We're also going to use the idea of the reference angle, which we were kind of talking about in the last chapter as well. And we're going to go through a decision-making process here so that where we can, we'll leave things in exact radian value. So if I can leave something as like 5 pi over 6, I definitely want to make sure that I leave it as 5 pi over 6 instead of a decimal value. Okay, so wherever possible, we'll express things exactly in their exact radian measure. Okay, so the decision-making process. The decision-making process is going to go through a set of 3 decisions that you're going to make. The first decision is, can I use a graph? Okay, graphs are nice because if it's sine or cos equal to 0, 1, or negative 1, we can solve that really quickly within one cycle between 0 to 2 pi. So this is only for if you have sine or cos x equal to 0, 1, or negative 1 for the most part. So if you know the graphs of sine and cosine from 0 to 2 pi, our 5 main key points can help us solve that really quickly. So this is your like sine x graph, where you have 0s, 1s, and negative 1s. Okay, and then for cos x, we know that our graph starts at a max, up at 1, and ends at a max at 2 pi. So those will be the 2 graphs that I'll use potentially for some solving if I can. The second one is, can I get one of these ratios, like for instance, if I have root 3 over 1 or root 3, I can get that from a triangle. So can we use a special triangle? Okay, and as we remember, our special triangles are the pi over 4, pi over 4, pi over 2 triangle, with ratios 1, 1, and root 2. And our second one is that was a bad triangle. Second one is the pi over 6, pi over 3, pi over 2 triangle with side ratios 1, root 3, and 2. Okay, so if I can get one of those from my special triangle plus using the quadrants, I'll make sure that I get that exact value from the unit circle. And then if not, then we use calculator. That's the last resort. Okay, so if we've gone through decision 1 and decision 2 and we've said no to both, then we will resort to using our calculator. Okay, so if I've used my triangles and I find that one of those could give me the ratio, I can find the other angle in the other quadrant by using 2 pi minus the reference angle, pi plus the reference angle, and pi minus the reference angle. I'll show you how we'll use that. Okay. Find all solutions for cos theta equals negative root 3 over 2 in the interval where x is between, or sorry, this should say theta, just kidding, where theta is between 0 and 2 pi. Okay, so first rotation around this quadrant grid only. So we're going to go through the decision process. One is, can I use a graph to solve this? Is cos theta equal to 1, 0, or negative 1 here? Is cos theta equal to 1, 0, or negative 1 here at all? Not a trick question. Look at this number. Is it 1, 0, or negative 1? Then we can't use a graph. Okay, can I get root 3 over 2 from a special triangle?
Yeah.
I think so. Which one?
The on the right.
It would be what's called the pi over 6 pi over 3.
Okay, so if we look at our pi over 6, pi over 3 triangle, which one is going to give me a cosine that will be a root 3 over 2? Would it be pi over 6 or pi over 3? That gives me an adjacent over a hypotenuse of root 3 over 2. Yes, so my reference angle here is going to be pi over 6 radians. All right, so let's think about this for a second. I have cosine between 0 and 2 pi radians, and it's equal to a negative. So I can have two possible answers here. Oh, sorry. I can have two possible answers here. Where would they fall?
The sine or like sine or what's it called, tan quadrant.
Great. So thinking about the cast rule here.
2 or 3.
Right. Our possible answers will fall in the sine or the tan quadrant because that's where cosine is negative. Okay, so cosine is equal to negative root 3 over 2. So that's how we know it's in those particular quadrants. So we're going to place our angles in these quadrants. And I know the reference angle there is pi over 6. And your reference angle is always placed between your arm and the closest x-axis. Okay, we're going to call this theta 1 and theta 2. So theta 1, if you use your little reference grid up here, it's just pi minus the reference angle. We want it to be before pi over 6 units before pi. So we'll do pi minus pi over 6. If you're not sure what that is, you can find a common denominator. And that is the location of 5 pi over 6 radians. Okay, the unit circle or the radian circle that we learned last chapter can also be helpful for this. Okay, for the second theta, we're going to do, it's pi over 6 units, or radians, I should say, past pi. So we're going to do pi plus pi over 6 in order to solve for this. Okay, and you can see in that summary that I wrote above, to calculate in this quadrant, we would do pi plus the reference angle. Okay, so we're going to do pi plus pi over 6. Again, if you need to, you can do common denominator. Oh, sorry, that's plus. And we should get 7 pi over 6 radians. Okay, so wherever possible, we're going to aim to leave those in those exact radian values, like 5 pi over 6, 7 pi over 6, 3 pi over 4, all that kind of stuff. So that's what the decision-making process helps us with, basically. Okay, how can we check our answers here?
Evaluate the calculator?
Sure. So if you figure out what negative root 3 over 2 is as a decimal, and if you type in the sine of 5 pi over 6, or sorry, the cos of 5 pi over 6 and the cos of 7 pi over 6, we should get negative root 3 over 2 for both of these. Okay? So that would be how you do a quick little check. You're going to plug back in and see if you get out the correct answer to what you started with in the question. Okay, if I happen to plug in my angle and I get the cosine of my angle, let's say I found it to be 11 pi over 6 or something like that, you're still going to get the value of root 3 over 2, but it will be positive if you found it in the wrong quadrant. So you just have to be very careful about that. It's going to look very similar to, like, it's going to look like it's right, except it will have the wrong sign if you found it in the wrong quadrant. So you do have to really pay attention to the fact that this is negative, and we want to get out negative answers when we check our angles in our original equation. Okay? So pay attention to your negatives and positives. Questions so far? Okay, we've done some solving stuff like this before in grade 11. The only difference now is we're doing it in radians. Can I scroll? Take that as a yes. Find all solutions for tan theta equals 5 in the interval, sorry, again I have an X here, in the interval where theta goes from 0 to 2 pi.
We have to use calculator.
Well, let's go through the process. Can we use a graph here? So we can only use a graph for the most part if we have sine x or cos x equal to 0, 1, or negative 1. So if you don't have that, then you're saying no for graph. So do we have sine, cos, or theta equal to 0, 1, or negative 1? No. So graph is a no on that. Can we get 5 from a special triangle? Not going to happen. So we go to calculator. How do I separate like tan and theta in my calculator? Like how do I get theta by itself?
Inverse of tan.
Right, so we're gonna have to do tan inverse of our angle, or sorry, of our ratio value. And I should expect that, again, I'll get 2 answers between 0 and 2 pi. Where will my answers fall?
It would be, what's it called? So if it's 10, that should be sine. So it would be 10 in all.
Okay, so tan is equal to a positive value. So I would be finding angles in the all quadrant where all trig ratios give me positive values. And then in its own quadrant, the tan quadrant, because tan is positive in its own quadrant. Okay, so we're going to find an angle here and here where the reference angles between the angle and the horizontal are equal. These are also opposite angles. If you notice the X pattern here, this angle and this angle must be equal. Okay, so we're going to make sure that we're in radian mode. Okay, so you cannot do this in degree mode. We're working in radians. So let's do tan inverse of 5. I'm sure some of you have done it already. What'd you guys get? 1.378, was it? 373. Okay, so let's just say 1.373 radians. Okay, this is okay. Pi over 2, if we wrote pi over 2 as a decimal, what would that approximately be equal to? Can someone calculate what is pi over 2? Not like sine of pi over 2 or anything like that, but just like what is the value of pi divided by 2?
It's like 1.57.
Okay, so does it make sense if I'm looking for something in the first quadrant that my answer for the all quadrant is 1.373 radians?
Yeah.
Okay, so that's acceptable, right? 1.373 radians in the first quadrant. We'll call that maybe theta 1. Okay, theta 2 also has that as a reference angle, 1.373. But we have to calculate the whole rotation starting from 0 all the way over to this line. So how can we calculate that? Jonathan?
Pi plus 1.373.
Okay, pi plus the reference angle here. So it'll be pi plus 3.73, and we'll round to 3 decimals.
That would be 4.515.
4.515, everyone else get that? Awesome. So those are our 2 answers. Now, if you guys do a quick little check, if you evaluate the tan of 1.373 on your calculator, you should get really close to 5. And then if you evaluate tan of 4.515, we should again get really close to positive 5. So we would check that in our calculator, make sure that our answer is right. There should be no reason why we don't know if our answer is correct or not, leaving that question, right? We can always know for these ones. So far, so good?
Wait, sorry, where did we get 1.373?
We did tan inverse of 5 on our calculator. That's okay. Just make sure you're in radian mode. Can I scroll? Okay. Find all solutions for 2 sine x plus 1 equals 0 in the interval where x is between 0 and 2 pi, so first rotation only. I think we need to get sine x by itself here, so I'm just going to start. We'll move the 1 over, we'll get negative 1, and then I'm going to divide out the 2. So really I'm solving for where sine x is equal to 1 over 2. So isolate for your trig ratio if you get something like this. Where should we expect possible answers to fall here?
Somewhat trying.
So sine here is equal to a negative. So we are expecting to find angles that will fall in the tan quadrant and in the cosine quadrant, where these 2 reference angles, where our angles are and between the horizontal, are going to be equal angles. Okay, let's go through our decision-making process here. Do we have sine or cosine equal to 1, 0, or negative 1?
No.
Okay, so it's going to be a no for the graph. Triangle. Can I get 1 over 2 from a triangle?
Yes.
Which triangle?
That would be, what's it called?
45, 45, 45.
No.
Yes.
Wait, 1 over root 2.
Wait, 1 over root, yeah, no, never mind, that would be the,
30 and 60.
Right, so the pi over 6,
Yeah.
pi over 3 triangle. Okay, what angle is going to give us an opposite over a hypotenuse of 1 over 2? I need an opposite over a hypotenuse. Pi over 6, that's right. So my reference angle is pi over 6 because that would give me an opposite over a hypotenuse of 1 over 2. And because we're talking about sine, that's the ratio that it's giving me out, right? It's giving me out opposite over hypotenuse. Now this is not a possible angle. Why is pi over 6 not a possible answer for this? The sine of pi over 6 is positive 1 over 2, yes. So that's actually just telling us this little slice inside here. It's telling us pi over 6 and pi over 6 is the reference angle. But we need to figure out theta 1 and theta 2, or sorry, I should maybe call it x1 and x2, in the correct quadrants. That will give us negative 1 over 2 for sine. So x1. I want the rotation from 0 to pi plus an extra pi over 6. So I'm going to do pi plus pi over 6. Okay, we did this calculation in an earlier question. It ended up being 7 pi over 6. Okay, if you're not sure, find the common denominator. And x2, how could we calculate x2? We want the rotation from 0, whoops, from 0 all the way to here. So a full rotation around is 2 pi. I want pi over 6 less than that. I want pi over 6 before we hit 2 pi. So I'm going to do 2 pi minus pi over 6. Okay, so that's like 12 pi over 6 minus pi over 6 gives us 11 pi over 6 radians. Pierce.
Sorry, so where do we get the 2 pi again?
So a full rotation around, if we're looking at like this from here all the way to here, how far is that?
I just got 2 pi.
2 pi. But I want pi over 6 before that. So I will take my full rotation of 2 pi and then I'll just subtract that little slice of pi over 6 and I'll get that angle there. Okay? If you're ever not sure, this is a really helpful reference. So it will always be, if it's in that quadrant, 2 pi minus the reference angle, if you forget. Yeah, I usually do give it. Okay, any other questions for this one? So how can we check our answer again? Pierce?
Get the decimal, then plug it back in our calculator.
I mean, you don't even need the decimal necessarily, but we're just going to plug it right inside here. And we're going to make sure that once we calculate this, we get 0 for each of these things. Okay, so plug your values back in for the angle measurement and check. All right, last one for the day. We are going to start by dividing out 3. I want to get tan x isolated. And then we're going to move the 1 to the other side. So we'll get 2 over 3 minus 1, which gives us, if we think about 1 as 3 over 3, that gives us negative 1 over 3. Okay, we're going to go through the decision process now. Can I use a graph to solve this?
No.
Nope. Can I get 1 over 3 from a triangle?
Yes. No, just kidding.
Root 3, 1 over root 3 I could, but not 3. So we're going to go calculator on this one. So firstly, before we use our calculator, where should we expect our answers to fall when we calculate here? Jeremy says C and S. Do you guys agree? Yeah. This is where tan is negative, right? So if tan is equal to a negative value, it must fall in the sine and cosine quadrant. So that's good. Okay, where the angles opposite to one another and between the horizontals will be equal. So both of those will give a reference angle. Okay, I'm going to make a little suggestion. You don't have to do this, but it makes your life much easier. When you have any trig ratio equal to a negative, I would suggest that when you find the actual reference angle, which is the angle kind of like between these slices here, that you do the inverse of the positive version of that ratio, okay? And that will actually just give you the reference angle that you need. It gets a little bit confusing when you start doing inverses of negatives because you can sometimes get negative angles. And as the question says, we want to make sure that our angle falls between 0 and 2 pi. So my suggestion is that when you calculate the reference angle here, let's let it be equal to theta. I'm actually going to do theta will be equal to the tan inverse of the positive ratio of this, 1/3, not the negative ratio. And again, you can do tan inverse of -1/3, but I'm pretty much going to guarantee to you now that you're going to get a negative angle, or you're going to get something that will confuse you. So just trust me on this one. To find your reference angle, do the inverse of the positive if you're using the calculator. We'll round to, let's say, 3 decimal places. And what do we get? Alex?
0.32.
3 decimals?
1/7,
2? Okay. So did everyone else get the same thing? Okay, so that's the little space in between here. Now we need to find, let's call this maybe x1 and x2. We need to find x1 and x2.
What is that?
So pi minus the reference angle in quadrant 2 will be pi minus 0.322. That will give us our x1.
2 pi minus.
Yep, and then we'll do 2 pi minus the reference angle in that last quadrant there. Alexandra?
The first one is 2, how many decimals do you want?
3.
2.8195, so
820, essentially.
0.8.
Radians. Okay, and then the second one.
5.96.
3 decimals, please.
Sorry?
3 decimals.
Yeah. Oh, so you want 3? 1.
961.
Yeah.
Everyone else get that? Pierce? You got 5.951? Okay, let's get somebody else to check this. 2 pi minus 0.322. Make sure we get the right answer.
Sorry, I made a mistake.
Okay.
Put, 3 instead of 3.
Okay. So that one's probably good. Okay, we can always check our answers again by plugging these back in for x and making sure that once we add 1 and multiply by 3, we actually do get left side equals right side equal to 2 here. Just for your purposes, shh, give me like 2 more seconds here, guys. Just for your purposes, if you are using calculator, Fayak, give me a couple seconds, okay? If you, let's say, you get cos theta equals 0, and we talked about how if we have sine or cos equal to 0, 1, or -1, we can use graph. So if you decide you can use graph to solve this, you're just going to do a quick little sketch of cosine, which is like this. And I would want to find the angles where cos is equal to 0. So cos is equal to 0 here and here. This is at pi over 2. So if you just label with the outsides of your quadrants, like these are essentially just the key points of cosine found from the outsides here. Where is cos theta equal to 0? What are my thetas that make this happen? Yep, pi over 2 and 3 pi over 2. So that one's super quick. Okay, and those would be your answers. You can double check on your calculator as well and make sure that when you plug those in, you get 0. If you got cos of -1, that actually only has one answer. What is the one answer for where cos theta equals -1 between 0 and 2 pi? Yeah, it happens down here, right, at pi. So when you have 1s, 0s, and -1s, a lot of times you might only get one answer for the 1s and the -1s. Sine of 0 has 3 answers between 0 and 2 pi because the graph crosses the x-axis 3 times for sine. So just take a look at your graph and make sure that you don't do more angles than necessary, or that you make sure that you get all of the angles between 0 and 2 pi. Cool?